Question 6 of your specimen is quite difficult. Okay, so let's follow through with the working first. So first part 6a, you're given the criteria or condition by which you have A cross B. Okay, you have A cross B equals to C cross A. And then you have the criteria B is not equals to minus C. So question's objective is to state a linear relationship between A, B, and C. So first thing first, your C cross A, I'm going to rewrite it as negative of A cross C and bring this whole thing to the left-hand side. And then you're going to factor out your vector A. Okay, and you'll see A cross B plus C is equal to 0. So vector cross vector to become a 0 vector, basically it means that they are going to be parallel. Okay, they are going to be parallel. So vector A must be parallel to vector B plus C. Okay, so that's the geometrical relationship. But the question asks for a linear relationship. So if they are parallel, that means A must be a scalar multiple of B plus C. That is your 6A. To take on 6B, it is rather difficult. So the trick to do this question is let V be X, Y, and Z. Okay, so when you let V to be X, Y, and Z, you actually go through with the cross product process. Okay, you have only this way to go through and try and investigate what is actually happening. Okay, so seriously, there's no what we call standard template to take on this question. So what happens when you do a cross product? Okay, you have x, y, z cross with 1, 0, minus 3. And you will see this whole thing, this vector negative 3y, z plus 3x minus y must be equals to another vector, 0, 2, 0. Okay, so at this point, what does it actually mean? So when you look at it, look across it horizontally, you'll see that y actually turns out to be 0 based on equation 1 and equation 3. Okay, and then from equation 2, you'll see that 3x plus z is equals to 2. So you have these two criteria to be met. Okay, you have these two criteria to be met. You have 3 unknowns, 3 unknowns and 2 equation. Confirm cannot solve for x, y, and z. 3 unknown, 2 equation will always generate 1 unknown. So from the context of vectors, this is what we call a typical line scenario. Okay, line scenario. So from here, what we'll do is that you re-express and make x the subject. So x will be equals to z minus 2 over minus 3, and y will be equals to 0. So at this point in time, look at it and actually realize that this looks very, very familiar. It's something like a Cartesian equation of your line. So you can always write it like that. Equals to z minus 2 over minus 3. Then you have y equals to 0. Okay, so this being a typical Cartesian equation of a line, change it into something that you know how to read. It is going to be like this. Okay, and that will be actually what your V is all about. V is a set of points, okay, that satisfy this equation. So your part 1 answer, okay, question asks for find a set of vectors V. So basically V will be any point lying on this line. Okay, V will be any point lying on this line. Okay, that is your first part answer. Then the second part of the question asks you to actually describe these position vectors geometrically. So explain in words. So V will be a set of points, okay, lying on the line, passing through 0, 0, 2 and parallel to 1, 0, minus 3.